Welcome to the Live Energy Connect Configuration Manager tutorial. Creating an ICCP client configuration with LEC Configuration Manager Part 1. Creating VMDs with LCM. Before you begin, we recommend you watch the LEC Configuration Manager introductory video and the Configuration Manager tutorial series on Oracle University at education.oracle.com. In this tutorial, I'll show you how to create a new configuration from a blank template, create 3 new VMDs within the LEC server configuration, and how to save your new LEC server configuration. Here is a conceptual diagram of an empty configuration. You'll notice there's already a VMD present in the LEC server, the configuration VMD. The configuration VMD is essential because it allows us to configure the LEC server from the Configuration Manager GUI. Every LEC server configuration will have a configuration VMD. VMDs act as containers for nodes, which we'll learn more about in Part 2 of this tutorial. The configuration VMD is the only constant among all configurations in LEC server. So when starting from a blank configuration, you'll need to create and connect other VMDs. Most LEC server configurations contain a processor VMD. Therefore, we will need to create a processor VMD in our ICCP client configuration. The processor VMD is also a hub for routing data, and it's used as a proxy so any local VMD in a configuration can communicate with another local VMD. The processor VMD also provides any required data filtering or transformation on the data passing through, such as changing its data type, scaling, or applying logic. In addition to a processor VMD, our ICCP client configuration is going to need a VMD to serve as the interface to our ICCP peer. This ICCP VMD is called a VCC. The ICCP communication protocol is built on top of an older specification called Manufacturing Message Specification, or MMS. The acronym VMD is a specific term borrowed from the MMS specification that we use in LEC server. So in essence, a VMD is a container or virtual device. VCCs are specific to the ICCP protocol. The acronym VCC is a specific term borrowed from the ICCP protocol, but essentially, a VCC is a container or virtual device in our LEC server that is used for ICCP communication. Now keep in mind, all VCCs in an LEC server configuration are VMDs, but not all VMDs are VCCs. The VCC we're creating in this tutorial will serve as an ICCP client that makes an ICCP association with the remote SCADA system. To make an ICCP association, both parties need to know certain parameters and information about their own VCC and the other party's VCC. Typically, when two parties are setting up an ICCP association, they share the ICCP association information with each other by filling out and exchanging a document called Association Information Exchange Form, or AIEF. Keep in mind, a single VCC can make associations with more than one VCC, and a VCC can serve as an ICCP client and an ICCP server simultaneously. This is known as a dual-role VCC. In addition to our processor VMD and our VCC VMD, in this tutorial, we're going to create something called a script VMD. We don't need this script VMD to complete our ICCP peer configuration. Our LEC configuration could function as an ICCP client with just a configuration manager VMD, processor VMD, and VCC VMD. But the script VMD is a nice add-on to our configuration to demonstrate how customers can add custom behavior to their LEC server configurations by using LEC server's Python scripting interface. A script VMD acts as an interface to a Python script running in LEC's embedded real-time Python interpreter. You can create your own scripts or use one of the many scripts that come with the LEC installer. In this tutorial, our script VMD will be an interface to a Python script called point logger. The script VMD will get point values from the processor, and as they come in, write the values of the points to a specified log file. Keep in mind, the script VMD we will use in this tutorial is not complex, but script VMDs provide the ability to perform complex filtering and can be used to quickly create interfaces to non-standard external applications. When you open LEC Configuration Manager for the first time, from the Node Table tab on the central panel, you'll see this mostly empty screen because we haven't created any VMDs or nodes. However, on the left column, notice this configuration VMD, which is the only constant among all configurations in LEC Server. As we create more VMDs, additional columns like this configuration VMD will appear on our node table. To bring things full circle for you, in the diagram I showed you earlier, the configuration VMD, represented here, represents the configuration manager here. Now, while it's likely an LEC Utilities Professional Services Engineer will help you set up your first configuration by providing a configuration.db to import into Configuration Manager, keep in mind, you may want to add devices as time goes on, so it's important that you know how to create and edit virtual devices and nodes. Now, let's jump into our demo. In the bottom left corner of the Configuration Manager, you'll see a few tabs. The VMD tab is what we'll use to create a VMD. Each VMD can communicate with another VMD inside and outside the LEC server. When you click the VMD tab, notice the list of VMD templates you can use depending on the configuration you're trying to make. To help determine the right template, hover your cursor over the VMD template name and read its description. Remember, most VMD types are intended to handle communications inside and outside LEC server using a particular communications protocol or interface. To begin, I'll need to open an empty configuration, so I'll go to the File menu and click Import Configuration. I'll navigate to my C drive, and then to the Program Data folder, and then to the Live Energy Connect folder. And from the list of files, I'll select empty template.db. And then I'll click Open. If you get this message, it means there is already a configuration file open, and it's asking you to save the currently loaded configuration file. I'm going to click OK because I don't want to save the open configuration. If you get this message, it means the configuration file you're importing doesn't contain the latest macro definitions included with your installation of LEC Server, and you'll need to update them. So I'll click OK to this message and click File, Reload Macros. This message is just telling us LEC Server needs to be running to reload the macros. I'll click OK to this message to start the process. A Windows console window will open and then close when the macros are successfully reloaded. Great! Now our macros are updated for the empty configuration file we just imported. And here is our Configuration Manager VMD, which, as I mentioned before, is included in every new configuration. Now, let's create our first VMD, the Processor VMD. Remember, any local VMD in a configuration can communicate with any other local VMD using a Processor VMD as a proxy. Now, going back to our Templates panel, on the left side of our application, from the VMD tab, I'll click Processor Create from my list. And in the VMD name field, I'll type processor. You can leave the flags and master INIT fields blank and then go ahead and click OK to add the processor VMD. Perfect. Now we can see our processor VMD column on the Node Table tab next to our Configuration Manager VMD. Next, let's create a local VCC. Our VMD tab on the Templates panel is already open, so I'll just click VCC Create from our list of templates. The VCC VMD has many more parameters than the processor VMD because the parameters are required to be defined by the ICCP protocol. For more information about each specific VCC parameter, see the ICCP reference appendix and the LEC Configuration Manager user guide. And while you're using LEC Configuration Manager, you can always hover your cursor over any field name to see the information about that field. Now, in the My VMD field, I'll type VCC _A. This is where we name the VMD we're going to use. In the ASSOC Out field, I'll type the number 1. And in the ASSOC In field, I'll type 0. This means VCCA will attempt to make an outbound ICCP association with its remote peer as opposed to listening for an inbound association. Now let's set the client role to 1 and set the server role to 0. Remember, in this scenario, the local VCC is just an ICCP client. In the Flags field, select Set next to Reduce List Flag. This flag lets LEC server adjust which points it includes in its transfer set requests if one or more of those points don't exist on the remote ICCP server. Now, in the My Domain field, type DOM A. The My BT ID field specifies the local VCC's bilateral table ID. So I'll go ahead and type 1_0. I'll type 1996,8 for the version. And in the My Features field, I need to specify a 12-bit string, so I'll type 11011 and add 7 zeros after. This string means the VCC supports ICCP blocks 1, 2, 4, and 5. Great. Now, in the remote VCC field, I'll type VCC_B. DOM B is going to be our remote domain. The remote BT ID is going to be 2_0. The remote version will be 1996,8. The remote features will be the same 12-bit string we typed in the My Features field. So I'll just copy that string and paste it into this field. We'll leave delay base, value poll time, and value timeout fields blank. I'll go ahead and click OK to close this window. And as you can see from our node table, we have a third VMD VCC-A. Next, I'll need to specify some additional parameters for the ICCP association between our local VCC, VCC-A, and the remote VCC, VCC-B. In this tutorial, these parameters have been predefined for us. In real life, your organization and your peer organization would together decide on these parameters and specify them in the AIEF forms you prepare when planning the ICCP association. So let's specify our parameters by opening the LDIB Editor tab from the central panel. If you don't see the VMDs you just created, click the Refresh button from the bottom left side of the window to display them. I'll need to specify the network connection and ICCP association parameters for VCC-A. In this case, I'll leave the network address as it is. I'll set the T-cell ASCII field to 00/01. Notice this also updates the T-cell field to 30, 30, 20, 30, 31. I'll set the SSEL field to 00/01 and the P-cell field to 00/00/01. I'll add 2, 16, 3826, 86, 67, 67, 65, 73 to the AP title field and set the AE qualifier field to 101. Leave the remaining fields as their default values and click Apply at the bottom right side of the central panel. Next, I'll specify the ICCP association parameters for the remote VCC, VCC-B. We need to change the parameters for VCC-B, but this time, in the network address field, I'll specify an IP address and port on which our remote ICCP peer will listen. Since our LEC client configuration is going to connect to a remote SCADA system that's just another instance of LEC server running on the same computer but on port 103, I'll type 127.0.0.1:103 in the network address field. In the T-cell ASCII field, I'll type 00/02, which will auto-update the T-cell field to 30/30/20/30/32. I'll set the SSEL field to 00/02. I'll copy the information from VCC-A's P-cell field and change the 1 to 2. I'll copy the information from VCC-A's AP title field and change the 65 to 66. And I'll set the AE qualifier field to 202. Leave the remaining fields as their default values and click Apply at the bottom of the screen to complete this step. Now, let's create our script VMD. Again, this VMD isn't required in a simple ICCP client configuration, but creating it will show us how we can use LEC Server's Python scripting interface to add additional functionality to our configuration. We'll go back to our Templates panel, and from the VMD tab, click Script Create. In the My VMD field, type Logger. In the Flags field, select Set next to ICCP flag, which allows this script VMD to know about the standard ICCP data types. Leave the script file field blank because this is not where we specify the script associated with a VMD script. Leave the remaining fields blank as well, and then click OK to close this window and complete this step. Now, if you go to the Node Table tab, you'll see a new column for the script VMD, Logger. Finally, let's arrange the VMDs in the node monitor. Before creating the nodes and connectors between those nodes within each VMD, it's helpful to arrange the VMDs in the configuration manager so the arrangement logically represents the data flow we're creating. Typically, in engineering diagrams, data flows from left, input, to right, output. To arrange our VMDs, we'll need to click the Node Table tab from the central panel and right-click the processor VMD. Select VCCA and drag it in between the configuration and processor VMDs. This updates the order in which the VMDs display on the node table. If you want to hide a VMD, just click the check mark to uncheck it. Now, let's save our configuration. I'll click the X to close this window, and go to my File menu and click Save Configuration. For the purposes of this tutorial, I'll save my configuration in the Live Energy Connect folder and call it myconfiguration.db. I'll click Save to complete this step. In part 1 of this tutorial, I showed you how to create a new configuration from a blank template, create 3 new VMDs within the LEC server configuration, and how to save a new configuration in LEC Configuration Manager. Be on the lookout for more videos in this series at Oracle University at education.oracle.com. Thanks for watching, and be well.